Okay, today we're going to be talking about rational functions. And you studied this last year, and we'll go over it again. There's actually an extra unit for the higher level students. So rational functions. So let's just the Cambridge book is pretty good about this. The approach is they ask you to compare three functions. So y equals negative 2x plus 1. They ask you to compare y equals 3 times 1/2 x. And they ask you to look at the new function, y equals 8 over x. And you look at them and, you can make a quick sketch. Over here, it's a line. It's a line. It's decreasing, and the y-intercept is 1. So it kind of looks like this. It's a sketch. It's not the best graph in the world. That's fine. And then we had the exponential unit. So once again, we have our axis, right? We know that it starts at 3, the y-intercept is 3. But we know that because the rate is less than 1, and between 0 and 1, we know this function is decreasing, and we know the shape. It looks like this, and we know it's asymptotic to the x-axis. That's okay. Now let's take a look at our new function. We studied this last year, and you can always go to Desmos. You can always go to Desmos and plot this. If you recall it, you can kind of start to plot it. You can say, hey, you know what? This fraction, first of all, x equals 0 is it's restricted from the domain. So this is going to be an asymptote. And you also look at this fraction and you say, hey, you know what? Because that numerator can never be 0, this fraction can never be 0. So 0 is also, y equals 0 is also an asymptote. And from Desmos and your experience last year, you kind of know the shape of this. It kind of looks something like this, where it has the two branches like this. Now, I don't want to focus on this branch over here. I want to look at these three functions. They're all decreasing. They're all decreasing, but the question is, how are they decreasing differently, right? And the book's kind of interesting about that. If you look at the first function, if you look at y equals negative 2x plus 1, and you create a table of values, 0, 1, 2, 3, when x is 0, y is 1. When x is 1, y is negative 1, negative 3, negative 5. And so the point the book says is that, okay, when the change is fixed, so in this case, we're going plus 1, minus 2, plus 1, minus 2, plus 1, minus 2. Here, when the rate is fixed, when the x is fixed, the y is fixed. Okay. Well, let's look at the next function. But it's decreased once again. As x changes fixed, y changes in a fixed way. Okay, let's take a look at the next function. Y equals 3 times 1/2 to the x. Same idea. I'm going to do the same numbers. 0, 1, 2, 3, 4. And so once again, we see here, this is fixed. But what's going on in my denominator? For my y, well, when x is 0, I start at 3. Oh, you know what? I'm going to ask you to change some. I apologize. I wrote it in my notes. I changed it to an 8 to make it a little easier. Let's change this to an 8. Sorry about that. And let's change this to an 8. So when x is 0, y is 8. When x is 1, y is 4. When x is 2, y is 2. When x is 3, 1 and 1/2. Now, as this rate is fixed up here, as this change is fixed up here, what's going on in the denominator? This change is a rate. It's dividing by 2 each time. And so that's the definition, the idea here is that this change is a rate, or it's multiplying or dividing by each time. So as the change in x is fixed, the change in y is fixed, and then for the exponential, the change in x is fixed, but the change in y is a rate. What's going on with 8 over x, we'll see here, this is kind of cool, that, well, I'll do it down here. Yeah, I'll do it next to it. I'll do it next to it, sorry. What we see is, let's make a chart. Now, we can't put 0, so I'll start with 1. But I'll go 1, 2, 3, 4, 5, and I'll see what happens. Well, if I put like 8, 4, 8 over 3, 2, 1.4, I'm not really hitting anything fixed here. So I have, I have plus 1, plus 1, plus 1, plus 1. I'm sorry, x and y. So let's see, 8 divided by 1 is 8, 8 divided by 2 is 4, 8 divided by 3 is 3, which is approximately, it's about 2.6. 8 divided by 4 is 2, and 8 divided by 5 is 1.6, I apologize. So what's going on here? Is there a rate? Is there a change? There's neither. So you know what? So this is fixed, but this is neither. So let's change the axis. Let's change the axis. This would be kind of cool. Let's change our axis to 1, 2, 4, 8, 16. Let's see what happens to our y values. When x is 1, y is 8. When x is 2, y is 4. When x is 4, y is 2. When x is 8, y is 1. And when x is 16, it's half. And so the idea of the reciprocal function, this function, it's decreasing in the sense that this is a rate versus a rate. That's the idea. That was the whole idea behind, once again, these are all decreasing, but this is how the rational functions are decreasing. I'm not testing you on this. You're not going to be asked this. This idea of y equals 8, this is known as an inverse proportion. And that, it's this rate versus a rate. And you might have learned, y equals k over x, and xy equals k, and this was a constant of variation. Okay, let's move on. So, what does this look like? Well, the other name for this is known as the reciprocal function. Reciprocal function. And you saw before I started to talk about how we would even graph this. And you say, hey, you know what? The domain is restricted. X can't be 0. So that's a vertical asymptote. We saw that this fraction will never be 0. Therefore, y equals 0 is also an asymptote. And notation-wise, let me erase all this, sorry. Notation-wise, we would say the domain is x is all reals, and x can't be 0, and we would see the range is y is all reals, and y can't be 0. Now, that's 1, that's 2. Now let's go to where we're going. Last year you did study rational functions, so for the rest of the lesson, let's talk about rational functions. Rational functions. A rational function is a function in the form of P of x divided by Q of x. Can everyone see that over there? Yeah, perfect. Okay. Now, you studied this last year, and we're going to study 3 forms this year. No. So SL is going to study the first form that we're going to do, which the order of P of x is equal to Q of x. So there's 3 forms. This is SL only. So for example, y equals 2x plus 1 over x minus 2. This is what SL is going to study. So I'm going to do this first, and SL can then shut off the video. What HL has to do, HL also has to do is they're going to do y equals x plus 5 over x squared minus 2x plus 1. Let's make it 10. And HL is also going to do, this is new for this year, you didn't do this last year, you're also going to do y equals the quadratic over the linear. So let's get started. What we want to do is we want to look at these rational functions. We want to be able to get all the characteristics, and we want to be able to sketch them. Okay. Let's have a computer up. No, that's fine. Okay. Let's move back here. Sorry about that. Actually, you know what? No. I'm going to go over here. Sorry. Okay, let's begin. Y equals 3x plus 5 over x minus 2. Now, before we do this, just refresh your memory by go to Desmos, and I want you to put in y equals ax plus b over cx plus d. Fool around with the sliders so you know what this looks like. We just want a sense of what it looks like if we have to sketch. So fool around with your A, B, C, D. Have a sense of what you know it looks like. Okay, we're back. In general, you know it looks something like this, or, something like this, with the obviously shifts up and down, or it's over a little bit, but it's the idea with these 2 branches separated by asymptotes. So we have an idea we want to look for, right? No, I'm sorry. Good. So, I apologize. I wrote it here specifically, so I'm not making this up as I go along. Sorry about that. Number one, y equals negative 16 over x plus 5. Okay. What's going on here? Well, we know that x equals 5 is a vertical asymptote. Right. What else? What else do we know? Well, I'm looking at this. This is a very basic one. I know that this fraction can be never be 0, so y equals 0 is a horizontal asymptote. Asymptote. Okay. Am I ready to graph this? Yeah. So you got your ruler. You know that x equals 5. X equals 5. You know that y equals 0 is a horizontal asymptote. Now the question is, which one of those does it look like? And you can kind of make a test. What's going on? Plug in a value. Make a table. because you know something's going on to the left of 5, and you know something's going on to the right of 5. And because the asymptote is at y equals 0, it's going to be positive or negative. So let's stick something in here. How about negative 10? Well, negative 10 plus 5 is negative 5. Negative 16 divided by negative 5 is positive. If x is greater than 5, for example, 10 plus 5 is 15. Negative divided by positive is negative. So I know that positive, negative. Where did I get this point from? That's a y-intercept. That's a y-intercept. Oh, look, that's easy. When x equals 0, y equals... No, sorry. Yeah. Sorry. Where did I make a mistake? Where did I make a mistake? I apologize. I'm going to edit this out. Let's start over again. Is there anything else I can find? Well, I know that when x equals 0, y equals negative 16 over 5. What is negative 16 over 5? That's approximately, 3.2? Negative 3.2. This is our y-intercept. Okay, I'm ready to sketch this. So, are there any zeros? No, there's no zeros here. So we're good. So we grab the two axes. I know that x equals negative 5 is a vertical asymptote. I'm sorry. So we know that x equals negative 5 is the vertical asymptote. I also know that x equals 0, y equals 0 is a horizontal asymptote. I know that 0, negative 3 over 2, that's my y-intercept. And the question is, which one of these does it kind of look like? I'm going to make a table here because I know there's action to the left of negative 5 and there's something going on to the right of negative 5. So let's plug some values in. How about negative 10? Well, if I plug negative 10 here, I have negative over negative. It's going to be positive. What's an easy point to the left, to the right of negative 5? Sorry. We know that one of the values is negative. So let's do like 0. That would be easy. Negative 16.5, this is negative. So we kind of know where the branches are. Over here, here's an upper branch. Here's the lower branch. Good. Let's move on. Now let's move on to functions we're more familiar with. How about we look at y equals 3x plus 5 over x minus 2. So I asked you before to fool around with the Desmos. And the idea is this also is a rational function, and it's also going to look like this. So based on, let's see what information we can take from there. So we know that we're going to need some asymptotes. So, and you learned from last year, even this year. So let's see. Well, we know that x equals 2 is a vertical asymptote. We know that if x equals 0, y equals negative 2.5. So that's the y-intercept. Are there any zeros or x-intercepts? Yeah, set the denominator equal to 0. That's when a fraction is equal to 0. So 3x plus 5 equals 0. X equals negative 5 over a third. This is an x-intercept. Now, you might say, Mr. Adler, where's the other asymptote? Because these rational functions, they all have two asymptotes. Good question. Well, you learned last year that the vertical asymptote is y equals 3 over 1. Where did I get that? Sorry. Where did I get that from? Well, you took off the lead coefficients. It's the ratio of the lead coefficients. So it's the ratio of the lead coefficients. And it makes sense that if you think about that. Remember, when we're going to an asymptote, we're thinking about really big numbers like 10, 100, a million. If you look at this, when we get to really big numbers, the 5 and the -2 really don't influence the 3x and the x. So they're kind of like, it's like a horse race. They're competing with each other. So it's always going to be in the ratio of about 3 to 1. But I say about because the 5 and the 2 are there, and they never allow this fraction to get to a ratio of 3. Therefore, the horizontal asymptote is y equals 3. In this case, when you have ax plus b divided by cx plus d, the horizontal asymptote is a over c. Now, we're ready to sketch. Let's get our ruler. We make our axis. We draw in our vertical asymptote. The first one is x equals 2. Please remember to always use a pencil. The second vertical asymptote was y equals 3. Once again, this fraction will never, ever get to 3. It'll get close to it. It's just never getting there. X equals 2. Y equals 3. Okay, let's put some points. Actually, by putting the intercepts in, it'll help us determine the branches. So I know that the first y-intercept is 0, 2.5. I know that my x-intercept is negative 5/3. And so I kind of know, through experience, I know that it kind of looks like this. Here's the branch over here, and therefore the other branch is over here. Okay, and that's the idea. So, good. And I'm going to stop this video here, and then and that's the end for SL. See what you can do.